Atlas. Everyone is talking about it. Astronomers are scrambling, telescopes are catching every pixel of it, and the internet is already filled with more theories than facts. It's only the third interstellar object in human history, and by far the most mysterious. It's moving incredibly fast, showing anomalous light polarization, a tail that doesn't behave like a normal comet's, and right now, it's disappearing behind the sun. What's happening to it at this exact moment? Why is everyone so alarmed by its behavior? And most importantly, what have we actually learned about Atlas during the months it was racing toward our star? Today, no panic, no rumors, just facts. Let's break down what's really happening with ATLAS.
Before we start, make sure to subscribe to the channel and support our growth. Let's go!
To understand why Atlas became such a loud cosmic event, we need to rewind a few months, back to the moment of its discovery. Atlas was first spotted against the star field as a faint but unusually stable object moving far too fast to be a typical comet of our solar system. Early orbital calculations revealed something astonishing. Its trajectory wasn't closed, it was hyperbolic. And that can only mean one thing. It came from beyond our system. Astronomers expected that the third interstellar object would resemble either Oumuamua or Comet Borisov. But Atlas acted differently. Its brightness didn't change like that of normal icy nuclei. Its tail looked stretched and kinked, shaped by solar wind in an unpredictable way. And the polarization of the light it reflected was so unusual that several observation teams initially suspected instrument error. All this fueled an online chaos. Social networks exploded with claims ranging from a new type of comet to a fragment of an interstellar protoplanetary disk. Scientists, however, stayed cautious because to truly understand the object, they had to wait for the most important moment of its journey. And that moment has now arrived. Right now, Atlas is undergoing its closest pass by the Sun, a phase known as perihelion. The peak of perihelion occurred on October 29th, when the object passed about 210 million kilometers from our star. After perihelion, astronomers continued monitoring Atlas almost continuously. The object had just passed the hottest point of its orbit, so everyone was expecting one of two scenarios. Either it stabilizes, or it starts behaving like an exhausted interstellar comet, unstable, with brightness fluctuations and potential disintegration. The alarm came quickly. Between November 11th and 18th, telescopes observing Atlas began detecting strange, almost illogical behavior. The brightness of the nucleus changed, as if it were shifting or splitting. On individual frames, this could be dismissed as noise, atmospheric distortion, or poor focus. But when several independent observations showed the same pattern, it became clear that something real was happening. The breakthrough came thanks to stacking and animation. Astronomer Modzi and colleagues used a technique that combines dozens of frames into a clean, denoised, stabilized image. First, a slight blur of the nucleus, then a faint asymmetry. But when they compiled the full sequence into a time-lapse animation, something undeniable emerged. The nucleus of Atlas had split, not into two parts, as initially suspected, but into at least three distinct fragments. There are even signs of a possible fourth, faint, dim, but moving in sync with the others. Breakup alone is only part of the story. But there's a detail even stranger than fragmentation: its color. Why is Atlas not green or blue like most comets, but golden? Throughout its journey, Atlas behaved unlike normal comets, and even its color became part of the mystery. Before perihelion, observers noticed a warm tint in its coma. Not green, not blue, but something like gold mixed with dusty brown. After perihelion, the tone deepened, becoming warmer and less dominated by bluish plasma. And once the nucleus began to fragment, this golden hue became unmistakable. So why does it look this way? The answer came from spectroscopy. Observations from multiple observatories revealed a rare and striking pattern. emissions of carbon-bearing molecules were extremely low. This means Atlas is a carbon-depleted comet, and such chemistry shifts the spectrum away from greenish tones toward ochre, dusty, golden hues. Because large dust particles dominate the scattering of sunlight, the coma becomes golden or brownish gold. This is not just a visual curiosity, it's a clue to the object's past. The golden color and lack of carbon molecules indicate that Atlas formed in an extremely cold, carbon-poor region, likely at the outskirts of a foreign protoplanetary disk. Such a composition would make its nucleus fragile and porous, which may have directly contributed to its current breakup. So, Atlas is an interstellar visitor that survived perihelion, but couldn't withstand internal stresses and split into several fragments. Its chemistry, color, and behavior make it one of the most fascinating objects of the decade. But the most important question is, what happens next? After breaking apart, each piece of Atlas gained its own momentum, and that means their trajectories are no longer perfect copies of the original path. In situations like this, three outcomes are possible. 1. The fragments gradually dissipate into dust and gas, the standard fate of fragile comets. 2. Some pieces retain shape and mass, continuing as small, independent mini-comets. 3. And the most intriguing scenario, a fragment receives enough of a velocity change that its orbit noticeably deviates. Not enough to hit Earth tomorrow, of course, but enough to create new gravitational resonances, potential future orbit crossings, or even a new meteor stream in the distant future. And yes, theoretically, if a fragment altered its speed and direction in just the right way, its path could move closer to the inner solar system, meaning Earth could eventually find itself along its trajectory in the next few decades or centuries. Not a threat, but a scientifically interesting possibility that astronomers will now monitor very closely.